Now in the chapter 9 part 2 video, I talked about how we knew the vertex of this quadratic equation right here. We know the vertex because this 4 refers to my vertical shift, and if I rewrite this as x minus -3, that -3 refers to my horizontal shift. So I knew my vertex was going to be at when x is -3 and y is 4. So right here. Now that's great. But in this class, our quadratic functions don't typically look like this one. We normally have something like f of x equals x squared minus 7x plus 4, right? We have it in this form, not like this. So how am I supposed to find the vertex if my quadratic equation is in the wrong form? Luckily for us, there's an equation for that. So given your quadratic equation is in the form ax squared plus bx plus c, remember this is the standard form that we will find our quadratic equations in, I can find h to be -b over 2a, and I can find k by plugging h into our original function. So let's go ahead and find that. So I have h equals -b, which in our case is -2, over 2a. A in this case is -3. All right, let's do that. So this means I have -2 divided by -6. I can simplify this fraction. -2 over -6 is 1/3. So I have my h is -1/3. All right, so that tells me the x coordinate of our vertex. Our vertex is going to be h comma k. So I've got -1/3. I now can go in and substitute this -1/3 in to my function. So I would find f of -1/3. That gives me -3 times -1/3 squared minus 2 times -1/3 plus 1. Now I know this is quite a bit of fractions, but just remember when we're multiplying fractions, we multiply the numerator, and when we multiply fractions, and when we add fractions, they need to have the same denominator. So I have -3. -1/3 squared is going to give us a positive 1/9. -2 times a -1/3 is going to give me a positive 2/3 plus 1. Whoop. So -3 times -1 over 9 is going to be -3/9. That's -1/3. So now I have -1/3 plus 2/3. Now all these fractions have 3 in the denominator. How can I write 1 as a fraction with 3 in the denominator? Remember that any number divided by itself is 1. So I can write this as 3 over 3. Now I have -1/3 plus 2/3 is -1/3 plus 3/4. My answer is going to be 4/3. So my vertex is when x is -1/3, and then y, when we want to write this as an ordered pair, is 4/3. You can just ignore this extra parenthesis right there. I'm not quite sure why I put that in. All right, I think we should do another example in order to help us find our vertex. There's a couple other things here, though, I want to point out so we know how to graph our quadratic function. Friendly reminder that if my a is greater than 0, so positive, my graph is going to open up. And if my a is less than 0, so negative, my graph is going to open down. All right, let's take a look at this next example. I have my a is 2, b is 4, and c is 5. Let's find the vertex of this quadratic function that we can see is going to open up. All right, I have h equal to negative b, in this case, which is 4, over 2 times a, which is going to be 2 times 2. So that gives me negative 4 over 4, which just gives us a negative 1. So there's my h. That's my x value. And I need to determine my y of my vertex. Negative 1. So I'm going to substitute in this h. I have f of negative 1 equals 2 times negative 1 squared, and that square's on the outside. That's important to keep in mind. Plus 4 times negative 1 plus 5. That means I have 2 times negative 1 squared. Negative 1 squared is just 1, so 2 times 1 is 2. 4 times a negative 1 is going to give me a negative 4, and then I have a positive 5. So 2 minus 4 is negative 2, plus 5 is going to give me a positive 3. So I have that my vertex is when x is negative 1 and y is 3. All right, this next slide is just a summary of the graphing techniques we went over. We're going to see how these apply to functions other than quadratic functions when we start section 9.4 in the next video. So remember that if I have a vertical translation, I'm going to be adding or subtracting k. If I have a horizontal translation, I'm going to be translating h units to the left, so the negative direction, even though h is positive, or h units to the right, even though my h is negative. My graph will be shrunk if my a is greater than 1, vertically stretched if my a is greater than 1, and it'll shrink if it's less than 1. And it'll turn upside down if my a is less than 0. So a is negative. That means my graph is going to be upside down. So it's upside down when a is a negative. I hope that this video has proved helpful. I hope the worksheet that went along with it was helpful as well. In this next video, we're going to talk about different types of symmetry and working with types of functions that are not quadratic.